Morning,
Good
sir.
morning. So today we will discuss upon the construction of root locus. We have a few things we have already discussed in the previous class. I'll just brief you down those things and then we'll continue with the rest of the steps. So in previous class we have discussed on construction of root locus, the steps involved in it. So the first step is that you have seen that how the how you are going to find out the poles and zeros and all. Taking an example, you have found the poles and zeros, and you have also drawn poles and zeros, and you have drawn the branches as well, so which starts from the pole towards the zero. So second step, you have also started with taking an example of g of s h of s is equal to k by s plus 1, wherein in step 2 we have also seen that you have seen that number of branches, how many number of branches of the root locus is available can be found by finding out the poles and zeros, and whichever is greater. So based on that, you can see that by taking an example here, we have seen that number of zeros is 0 and number of poles is 1, and we have plotted those things here, and we got that one branch will be there. In step 3, we have also seen that taking another example, g of s h of s is equal to k into s plus 2 into s plus 3 divided by s plus 1 into s plus 4. So you understood that from this step 3 that the root locus exists in the real axis only in the left of that, and poles and zeros can be calculated here in this case by equating the numerator and denominator. We got numerator, we got zeros, and from the denominator we got poles. So s plus 1 is s plus 2 is equal to 0, s is equal to minus 2, s plus 3 is equal to 0, s is equal to minus 3, s plus 1 is equal to 0, s is equal to minus 1, and s plus 4 is equal to 0, s is equal to minus 4. Numerator we got all zeros. You can see the zeros here in minus 2 and minus 3, and then we got poles at minus 1 and minus 4. That's what we have done, and we have also drawn the branches from poles towards 0. So further in the step 4, we are in the process of finding out the asymptotes, and you know that asymptotes are the lines which are drawn. We can draw dotted lines at a certain angle by finding the centroid. So you have to mark the centroid in the axis, and then you have to find out the angle. You need to draw the lines. So this root locus, whatever you draw, will go parallel to the asymptote, and it meets at the infinity. So that is what we have seen there. So the root locus will meet at the infinity for the with the asymptotes. Okay. So there are few things here, few equations, three equations we have seen here. In order to find number of asymptotes must be equal to the number of zero. So number of asymptotes, how many asymptotes has to be drawn, can be decided by finding out pole minus zero. That is p minus zero. P is the number of finite poles, and z is the finite zeros. Then after that, we have also seen the angle that the asymptote makes, that can be used using the equation phi of A is equal to 2q plus 1 into 180 divided by p minus z. So this q value will be 0, 1, 2, 3, etc. And if you got p minus z as 1, then it is enough to find q is equal to 0. If you got p minus z as 2, you need to find q is equal to 0 and 1 also. Both two cases you need to find. 3 means you have to find 0, 1 and 2 for the values of q, 0, 1 and 2, and 1 and 2. So this is what we have seen. And there is a need to find the centroid in order to mark the point in the axis. So to mark the point in the axis, we have used the equation sigma A as summation of finite poles minus finite zeros divided by pole minus 0. And we used one of the example here. and we have also plotted for that. So g of s h of s is equal to k by s into s plus 1 into s plus 8. So here you know that the zeros are not available, but poles are available to be 3. So we have s is equal to 0, s is equal to minus 1, and s is equal to minus 8. The poles are available at those points, and you have to number of asymptotes is p minus z. So 3 minus number of poles is 3, 3 minus 0, you got it as 3. Centroid is also can be found by substituting the values summation of poles and the summation of zeros. So there is no 0 available, so we have put it as 0. Summation of poles, we have 0, minus 1 and minus 8. We need to do the sum and divided by pole minus 0, 3 minus 0. So we got it as minus 3. So further step is that you understood that the centroid is minus 3, and you also understood that you have 3 asymptotes to be drawn, and you also know that you have to substitute the values of q as 0, 1 and 2 in order to do this. So first we are going with q is equal to 0, we got 60 degree, q is equal to 1, we got 180 degree, and q is equal to 2, we got 300 degree. So this is what all we have discussed in the previous class, and we have also seen how the asymptotes has to be drawn in the previous class. So continuation of that, that is not the end of the root locus. We have to do lot many steps further. So here you can see that you have drawn put the centroid sigma a is equal to minus 3, and then you have also found the angles 60 degree. You have drawn an asymptote as1, and at 180 degree you have drawn another asymptote as2, and in 300 degree you have drawn another asymptote as3. So till here we have completed in the previous class. So we will move on further with step 5 as the continuation of that. Is there any doubts for anyone? It's clear for all of you till asymptotes?
Yes, sir.
Okay, fine. So let us move on further with step 5. So step 5, so I think all of you might have drawn this figure also in the previous class. So this was an example. We will be going through the problems also, where you will have to use all the steps and finally come out with the answer whether the how's the system performance. Okay. So step 5, in step 5, we can see that the complex roots must occur in conjugate pair. So what you can say is the complex roots must occur in conjugate pair. Therefore, the root locus plot is symmetrical about the real axis. So what you have to understand is the root locus plot need to be symmetrical about the real axis. So complex roots must occur in conjugate pair, and the root locus plot has to be symmetrical about the real axis. So you can see that whenever you draw that, no, you will, this is the real axis sigma. So you can see that the like the butterfly, same way you can see that you will have a symmetry. Most of the things, whatever it is there in nature, it is symmetrical. Similarly, you can see that in the case of root locus also, you can see that the sigma axis, all the real axis, the to this axis sigma, you have to have at the numerator, means both the sides has to be symmetric to each other. So the complex roots must occur in conjugate pair, and therefore the root locus plot is symmetrical about the real axis. So you can make a note of that. Now we are going to see step 6. So this step 5 is that you can see that it is symmetrical to real axis. So when you are plotting, no, you have to keep a track of those things. So next is step 6, that is breakaway point. So there are a few things like breakaway point and break-in point. So we will see that a breakaway point is the point at which the branches of the roots or root locus leave the real axis. So this is what, so when we are solving the problems, so you will see that we will be finding the breakaway point, and you will see that the branches are leaving the real axis and all those things. So breakaway point is the point at which the branches of the root locus leave the real axis, and it is the point of intersection of branches of the root locus. So the point at which the two branches return to the real axis is called break-in point. So that is the difference between the breakaway point and break-in point. Breakaway point means the point at which the branches of the root locus leave the real axis, and the point at which the branches return to the real axis is called as the break-in point. So we'll be doing some problems based on this, where you can see that we'll be understanding more about the breakaway point and break-in point. We have to see that which are the branches which of the root locus which leaves the real axis, and which are the branches of the root locus that uh, return to the real axis. So we'll be seeing that. So they are classified as a breakaway point as well as break-in point. So you might have uh, these are all few things which you have to keep track of it when you are finding out the solution for the problem. So you may have to go with the breakaway point or break-in point. Okay, we'll be solving the numerical, so it will be still more clear to understand these things. So it has to be today we have seen that the system or the root locus, whatever you plot, has to be real, has to be symmetric about the real axis. Also, we have seen that the breakaway points and break-in points. Breakaway point is the root locus that leave the real axis, and break-in point is the branches which return to the real axis. So you can make a note of all these things. So we will see few examples also. So so breakaway points occurs at so we will see that we will see in some problems we can see that breakaway points and break-in points are considered. So as well as all these steps whatever you have studied, it will be made use in that, like we'll be finding out the pole zeros, then we'll be finding out the uh, finding out the asymptotes at which angles, centroids, all those things. We have to see that it is symmetric to the real axis as well. And you have so also in some cases we'll be finding out the breakaway point and break-in point, and checking out that whether the branches return to the real axis, or the branches of the root locus leaves the real axis. So further on, you might have you can make a note of all these things, and then we'll proceed further. So these all steps are required for the construction of the root locus. So if you are going to plot the root locus, you have to keep track of all these points. You have to find out the number of poles, zeros, all those things. So when moving on further, the breakaway point it occurs at the point of maximum gain on the real axis between the open loop poles. So this is what you can see. The breakaway occurs at the point of maximum gain on the real axis between the open loop poles, and the gain at the break-in point, so is the maximum gain found along the real axis between the two zeros. So this is what the main thing about breakaway point and break-in point. This occurs at the maximum gain on the real axis between the two poles. So you will be drawing the poles and zeros. So breakaway point will be mainly focusing on the open loop poles, and break-in point has the maximum gain found along the real axis between the two zeros. So that is what you can see. We can see all this in the problems. So here, how we can calculate these things is by using the equation dk by ds is equal to 0. So you'll be finding out dk by ds, and you have to equate it to 0. You can go finding out all these points. Okay. So we have to understand these things in order to find. We'll be seeing one example as well, which will make you clear about this breakaway and break-in points. So breakaway or break-in points are the points where the branches of the root locus intersect. So intersects and at these points the value of k is always positive. So you can see that the where the break-in point or the break away points are there, the branches of the root locus will intersect, and at these points the value of k is always positive. So we have to now understand these things, whatever we have studied regarding the breakaway point and break-in point, with one example. We are going to take an example. G of s h of s is equal to k into s plus 1 into s plus 2 divided by s into s minus 1. So with this example we are going to see that how to discuss about the breakaway point as well as break-in point. So we have understood the concept of breakaway points and break-in points. So you can have all these things. You can make a note of all these things, and then we will take this example, and we will try to discuss upon those things. So when we have g of s h of s is equal to k into s plus 1 into s plus 2 divided by s into s plus s minus 1. So from this example, you can also go finding out the pole zeros and all those things, as well as we have to use the characteristic equation, that is 1 plus g of s h of s is equal to 0. So I am you have to just interrelate whatever you studied in module 3 as well. So that will be also helpful for you. So g of s h of s is equal to k into s plus 1 into s plus 2 divided by s into s minus 1. So you can make a note of these things, and then I will explain the example. So let us we have g of s h of s. So let us substitute g of s h of s in this 1 plus g of s h of s is equal to 0. So when I substitute, I'll get 1 plus k into s plus 1 into s plus 2 divided by s into s minus 1. So further, that is equal to 0. So 1 plus k into s plus 1 into s plus 2 divided by s into s minus 1. So now here you can find k when you simplify it for k, you can do that all the simplification steps, and when you simplify it, you will get it as minus of s square minus s divided by s square plus 3s plus 2. So that is what you're going to get for k. This is just simplification. When you simplify for k, you will get it as minus of s square minus s divided by s square plus 3s plus 2. So at breakaway point or and break-in point, what we have seen in the explanation, we have seen that we have to take dk by ds is equal to 0. So you need to take dk by ds is equal to 0. So what is here k? K is minus of s square plus minus s divided by s square plus 3s plus 2. So you need to take dk by ds and you have to equate it to 0. So you can try doing that dk by ds, and then you can equate it to 0. So breakaway point and break-in point, can be found by dk by ds is equal to 0. So you can just try it out, finding out dk by ds and then equating it to 0. So actually, you would have studied all these things in your basics when you are doing the differentiation and all those things. D of u by v of by dx can be written as v into du by dx minus u into dv by dx divided by v square. So this you have to remember and then do the simplification. So this you have studied before. So differentiating u by v, because it is minus of s square minus s divided by s square plus 3s plus 2. So you need to simplify that, can be done using this equation d u by v by dx, and that can be written as v into du by dx minus u into dv by dx divided by v square. Okay, when you do that, when you complete the differentiation for that section for k, you end up with this equation 2s square plus 2s minus 1 is equal to 0. So this is what you get it when you do that, and you will get 2s square plus 2s minus 1 is equal to 0. So from that, you can use the calculator or you can find out the roots, that is 2s square plus 2s minus 1 is equal to 0. So you can find out a value of s. So all of you can do that. You can find out that when you do this, you will get the values of s. So you'll get it as 2s square plus 2s plus minus 1 is equal to 0, and that is for dk by ds is equal to 0. You get it as 2s square plus 2s plus minus 1 is equal to 0. Now you have to find out the roots of the equation, and you can say that you will end up with s is equal to 0.366 and s is equal to minus 1.366. See, anyone of you have completed? You are still doing it? Yeah, students, you have completed?
Yes, sir.
Okay. So you got the values of S. Have you got the values of S as
Yes, sir.
0.366? You got it? Okay. 0.366 and S is equal to minus 1.366. So once you complete the values of S as 0. You get it as this one. Yes, 0.366 and S is equal to minus 1.366. So let us see further. So what we have to understand that now we have done dk by ds is equal to 0. So you end up with 2s square plus 2s minus 1 is equal to 0, and you got the values as 0.366 and minus 1.366. Now let us see that since 0.366, where it will lie on the real axis of the root locus between the poles. So the breakaway point, so it is a breakaway point. You understand carefully. Here we have also seen that few points here. This point is very important. Breakaway point occurs at the point of maximum gain in the real axis between the open loop poles. Break-in point is the maximum gain found along the real axis between the two zeros. So I have told you that when you equate it, s plus 1 and s plus 2, you'll get s is equal to minus 1 and s is equal to minus 2. And here s is equal to 0, you'll get s is equal to plus 1, you will get. So you understand that where is the zeros and where is the poles. Now you have taken this value 0.366. So where it will be? So you know that poles is there at s is equal to 0 and s is equal to 1. So when at s is equal to 0 and so let me just write the poles and zeros. So what you have here, s is equal to 1, sorry, s is equal to minus 1, and you have s is equal to, you know all these things, s is equal to minus 2, s is equal to minus 2, and then these are the poles, these are the zeros, and we have poles at s is equal to 0 and s is equal to 1. So you get these values here. So you should be very much clear. These are the things which we have studied before itself. So we have to understand these things, and so once you get these values, poles and zeros, so you can see that now I will just show you that 0.366. So 0.366, you have the values s is equal to 0 and 1. So 0.66 lies in the real axis roots between the poles. So it's breakaway. So it is what? Breakaway point. So we have already seen that breakaway point occurs in the maximum gain on the real axis and between the poles. So that point lies between the poles. So it has to be breakaway point. Now you see the next point, 1 minus 1.366. So where is that? So since minus 1.366 lie on the real axis between the two zeros, you can see that what are the zeros here? 1 and minus 1 and minus 2. So where it will be lying, minus 1.366 is between the two zeros. So whether it will be breakaway point or break-in point, it will be break-in point. So that is what you have to understand. So let me take you to the definition again. So the gain at the break-in point is the maximum gain found along the real axis between the two zeros. So if it is between the two zeros, you call it as break-in point, and if it is between the poles, you call it as breakaway point. So you got those values. Now you have to find the value of k. Now you understood that so this 0.366 is a breakaway point, and you can call 1.366 as break-in point. Now you are going to find out the value of k. So to find out the value of k at breakaway point, so how to do that? You take this equation, that is k is equal to minus of s square minus s divided by s square plus 3s plus 2. Use that equation and then substitute it for s is equal to 0.366 to get the breakaway point. So you get the breakaway at the value of k at the breakaway point. So you'll get the value of k when s is equal to 0.366. Substitute the values of s and do the calculation. You will end up with the answer 0.0718. So what you understand is the value of k at the breakaway point is 0.0718. You can make a note of all these things. So you got S is equal to 0.366, and from that you have found the value of K at the breakaway point. You got it as 0.0718. So what is this? This is the maximum value of K. So what value got here as the maximum value of K on the real axis of axis locus between the two poles. So that is this is the maximum value of K which is possible there. So you can just complete this off, then we will move on further. So we have understood many steps till date. So we have seen already how to find out the poles, how to find out how to draw the branches, and we have also seen that how the asymptotes are being plotted, how to find out the centroid, how to find the angle at which the asymptotes are placed, and then we have seen that there is a symmetry between the root locus, and we also have started understanding that how the uh, how to understand about the breakaway point and break-in point. So all these things we have to see that where we have also taken the differentiation of that, that is dk by ds is equal to 0, and we end up with the equation as an example here, 2s square plus 2s minus 1 is equal to 0. So we got all the values. We found the value of k at breakaway point, and we can say that this is the maximum value of k on the real axis, so between the two poles. Okay, so that is what we have done till now. Further we will continue this. You can keep a note of all these things. So is that over? Shall we go ahead? Is it clear for all of you till now? It's
Yes, sir.
clear, no? Okay. So you can make a note of it. When you complete it, just let us move further. So it's not that difficult. You have to do step by step process for each. When problem comes to you, you have to carry out each step as per the requirement, and complete one by one step. Okay. So I think you might have completed. We will proceed further. So is that over?
Yes, sir.
Okay. So we have done all these things. We have seen where the breakaway point and break-in points are available. We have also seen the zeros and poles. We have found the value of k at the breakaway point. That is, the breakaway point was 0.366. At that point, you have found the value of k, and you know that that is the maximum value of k on the real axis through a locus between the two poles. So a continuation of that. So the value of k you found for breakaway point. Let me just take you through the break-in point as well. So you know that s is equal to minus 0.366 is the break-in point. So the value of k at the break-in point you can find by substituting s is equal to minus 1.366 in this. So k you get it as s minus s square divided by s square plus 3s minus 3s plus 2. So substitute s is equal to minus 1.366. So when you do the substitution, you get the value of K as 13.928. This is an example. So I want to just take you through the break-in point as well as the breakaway point, and we have found that the value of K at the breakaway point as well as the value of K at break-in point. So in break-in point, it is 13.928. So this is the maximum value of K on the real axis between the two zeros. And from the you can just first you can plot the poles. So you have poles at the values. You have poles at the values uh, 0 and 1, and zeros at -1 and -2. So you can just plot that. So zeros at -1 and -2, and poles at 0 and 1. So first you can plot the poles and zeros. Uh, so you can put the branches also. And after that, now we have to go with the breakaway point and break-in point. So what is the value we have found for the breakaway point? So in the breakaway point, we got the value as 0.366. So let us put 0.36, as well as in break-in point, we got it as minus 1.366. So let us put those values in the figure. So I am putting it as 0.3 here, and minus 1.366, 2 points. Then you can just see that you have to draw it break in and break away. You have to understand. So you have to draw this arrow mark towards this side, from break away towards break in. Okay. So this also arrow mark, you can see that it is going towards the break in point. So that is what you have to put the arrow mark. So this is all about breakaway point and break-in point. So we will move on to the next step. You can just make a note of it. So the arrow mark, when you are putting it away means you have to move it towards that. So it will, arrow marks will be going towards the break-in point. So you can make a note of it and complete it. This figure for your reference you can do. This was an example we have quoted. So in step 7, you are going to see that the angle at which the root locus leaves the complex poles is called as the angle of departure. So you have to see the angle of departure, that is the angle at which the root locus leaves the complex poles is called as the angle of departure. And the angle of departure from the complex pole can be calculated by using the equation phi d. Phi d indicates the angle of departure, and it can be calculated as 180 minus summation of phi poles and summation of phi zeros. So the angle at which the root locus leaves the complex pole is called as the angle of departure. So phi d can be found by using this equation 180 minus summation of phi poles minus summation of phi zeros. You have seen the angle of departure. Similarly, we need to find the angle of arrival. So the angle at which the root locus arrive at the complex 0 is called the angle of arrival. So we have two things, angle of departure and angle of arrival. So angle of departure can be called as phi d, and the angle of arrival at the complex 0 is called as phi arrival, and it is calculated using the equation 180 minus summation of phi of zeros minus summation of phi of poles. So those things we can see when we do some problems. So the two things are there, that is angle of departure and angle of arrival, and the root locus which leaves the complex poles is called the angle of departure, and the angle at which the locus arrive at the complex zeros is called the angle of arrival. See, you can see that leaves the complex pole. I have marked it there. Leaves the complex pole is called as the angle of departure, and arrives at the complex 0 is called the angle of arrival. So you have the equation phi d is equal to 180 minus summation of poles minus phi of poles minus summation of phi of zeros. And arrival means 180 minus summation of phi of zeros minus summation phi of poles. A slight variation in the equation, you can see that pole minus 0, here it is 0 minus pole. So that is about phi d and phi arrival, that is departure, angle of departure and angle of arrival. You can note down those things. So further on, we have seen all the 7 steps now. Still few more steps are there. So the next step is step 8. We will see that. So you can note down those things. So step 8. So the step 8, what does that mean? Talk about is the points at which the branches of the root locus crosses the imaginary axis, and the value of k at j omega crossing can be obtained by by substituting s is equal to j omega. So we will be in some cases we have to do this, the points at which the branches of the root locus crossing the imaginary axis. So if it is crossing the imaginary axis, and the value of k at j omega crossing can be obtained by substituting s is equal to j omega in the characteristic equation. So what we'll be doing is we'll be substituting s is equal to j omega, and then we'll be equating it. So equating for the both the real and imaginary parts to 0, and solve for w and k. We'll be substituting s is equal to j omega in the characteristic equation, and we'll be finding out the imaginary parts to 0, equating the real and imaginary parts to 0, and solving for w and k. We have to find out the values of w and k. So we will be solving numericals where we'll be using all these concepts. So the last step, that is the 9th step, the value of k at any point s can be obtained by using the magnitude condition, that is magnitude of g of s h of s is equal to 1. The value of k at any point s can be obtained by using magnitude of g of s h of s is equal to 1. So you can just keep a note of all these things. Then next class we will be taking up a problem and we will be simplifying it. Before that, you can just go through all these things. Okay. So I will wind up for today. That's all for today. All the steps. Just I will summarize you. First, we have found the poles and zeros. We have also seen the how many number of poles and zeros are there. So based on that, the number of branches will be decided. And when you go further, you have seen that how the centroid is calculated, and then asymptotes are plotted, at which angle the asymptotes are there. You have also seen the breakaway point, break-in point, angle of departure, all those things. And we have also seen that substitution of s is equal to j omega, you can find the values of omega and k as all those things. So it's when you do the problem, it will be quite clear for you. If any doubts are there, we can discuss. So I will wind up for today. That's all for today. Thank you. Is it clear for everyone?
Yes, sir.
Okay, thank you.
Thank you, sir.